both the organizer and the speaker are organizing this meetup in individual capacity only. We are not representing our companies here. This presentation is strictly for learning purpose only. Organizer, presenter do not hold any responsibility that same solution will work for your business requirement. And this presentation is not meant for any promotional activities. So this presentation and this type of meetups are fully for learning, for guiding you to take a good path in your future. Some housekeeping. Okay. So the recording of this meetup will be in the meetup page where you have registered it. So if you want to go and see it uh, in your future, then you can go and do that. Okay. And I will try to upload it within 24 hours. And once the meetup is done, as you have registered, so you will get a feedback form. And it's my due request to you all. Please provide your feedback over there because that will help us to improve the meetup, to improve the group, and bring up new other topics what you want. Okay. So that's a humble request. Now coming to the organizers. So that's Yakub and that's me. So Akub is your super senior and alumni of this college, and with the help of him, with the help of Dr. Anurag, your HOD, we were able to conduct this. We are very thankful to BBD, to our faculties who has given us this opportunity where we can come and tell about MuleSoft, tell about the IT world. So Akib, would you like to introduce yourself?
Yeah, thanks, Abhishek. I would like to thank my say I have passed out from there in 2014, and I see there who used to teach us when I was in that. And thank you, Manish sir, for allowing us to hold this session in the BBD camp. So I have total around 9+ years of experience in IT world. I am chair, then moved to Infosys, then moved to Cognizant. Now I am with TCS. So I have, started when I started. I was working on Java, Spring, and all those technologies. Then I got the chance to work on this, which was introduced later. And since total 5 years of experience in developing APIs, and currently me and Abhishek both are co-hosts for Lucknow Meetup, and this opportunity son. Otherwise, we used to hold the session virtually, and we have our T+ sessions, which is available on our page. So that's it from my side. Abhishek, you can.
Thank you, Akib. So about me, so the photo might looks little different. That's an old one, but I'm a MuleSoft ambassador, a frequent speak. I keep on giving sessions on different topics over MuleSoft. I am a leader for Guwahati and Lucknow group. So the way we are doing session, there is one more group, Guwahati, which I lead. I am a certified MuleSoft developer architect. I have overall of 9 years of experience and overall 7 years of experience in MuleSoft. I'm a MuleSoft industry and GTM champion. I have certifications on Salesforce, Solis, Dell Boomi, Google Cloud Platform. I write technical blogs, create videos, and I also own a patent on creating a portable washing machine. So that's all about myself. Now let's move to the agenda, like what we are going to discuss today. And I just want you all to be interactive, asking questions. Feel free to ask whatever questions you want. Okay, don't fail, don't be shy. It's for learning. So this is your benefit, okay, which is going to help you in future. So talking about the agenda, what we are going to discuss today, we are going to give you an idea about what is MuleSoft, the closing IT operation model, API-led connectivity, API lifecycle, about Catalyst approach, and then I will show you what are the different learning platforms we have, okay, where you can go and learn about this technology. And believe me, it's going to be very helpful to you. Most of the things are free, so you can directly go log in and learn about that. Okay. So coming up to our topic, so what is integration? So who from you will define me what is integration, what you understand about it? Anyone? No one? What you know about integration? Would you like to define anything? Just in your words. I don't want to be very perfect. Just what you understand. Anyone else would like to try? Yeah. What's your name? Utkarsh. Thank you, Utkarsh.
Isma Patel. Basically, integration is like that integrating a user's demand that what users request into the platform where user can it can become interactive with the users. Just that users need what the user requires.
Yeah, Nitish, absolutely right. So that's how what integration is. So integration is in our daily world. Okay, even we are sitting with the integration at now, at present. So think about like this: we use Book My Show. Obviously, you might have used right for booking tickets, movie tickets, IRCTC, Amazon, Flipkart, all this. This all how it works. Okay, so when you open your Book My Show, it's very fascinating. Like you can open it by your desktop from your mobile phone. You can book your ticket. You don't have to be in the queue. Just from home, you can do that. Yeah, extra charges for internet you need to pay. That's fine, but you don't have to be in queue, right? So that looks very fascinating and it's on your palm now, everything on your palm, just on a click you can do that. But what is that? So that's what integration is. Okay, so an integration platform is a cohesive set of integration software or middleware, we can say, product that enable user to develop, secure, govern integration flows that connect diverse application systems, services and data store. Okay, so meeting the unique need of its user, and it bring various type of integration together in one place. So that means we are connecting different systems. Okay, we are connecting all different systems to meet the demand of the user. So as a user, when you are doing a demand from Book My Show, is connecting to several different systems to fulfill your and book a ticket for you and bring it to you. Okay, that's what I do. So you might see it fascinating, but behind the scene, what this is what happening behind the scene. This is what a developer, architect, a DevOps team, all all the integration experts do. So how it works? Like when you are searching for a movie, it will go to some web server. From web server, it will go to some application server where it will search for that. Then it will filter it out. So a lot of things are happening over there, and a lot of people are involved in doing this. Okay, so that's how the integration works, and that's how you get everything. Any question on this? Anyone, any view? Want to share anything? Okay. Now let's talk about MuleSoft. What's MuleSoft? So the aim of MuleSoft is to connect the world application, data, and device to transform business. So MuleSoft is an integration platform, okay, which help you to connect to different systems and fulfill the user's requirement. That's what MuleSoft do. Okay, it's an integration platform founded by Ross Mason and Dev in 2006, but made public. The IPO made public in 2017 and acquired by Salesforce in 2018. Okay, we have overall of 1800 plus customers and 1,75,000 plus developers worldwide who are working on MuleSoft, who are working in the back end to make things possible for you. That's what MuleSoft do. Now let's understand more about MuleSoft, like how it is derived. Okay. So word mule, it's a combination of donkey and horse. So donkey means representing repetitive work, and horse represents speed. So we are developer, we are innovators, right? Why we need to have a repetitive work? We don't want to do that. We want to innovate that. We want to have iterations. We want to have reusability, but not repeating things. Okay. So that's what MuleSoft come into play and help us to remove that donkey work, to remove that repetitive task, and make it easy for the user or the developer to work on it. Okay. So the platform emphasizes on ease of development, quicker, effective assembly of components, and less custom coding by hand. One more benefit of MuleSoft is we don't have much coding. It's a declarative tool where it's drag and drop. Okay. So if you are phobic with Java or different codes, then this is a best tool for you where you don't have to do a lot of coding. It's drag and drop. We have something called a scripting language DataWave, which is the heart of MuleSoft, you can say, which is required to do the transformations. Getting it? Any questions on this? You're listening me, right? Am I boring you? Okay. So now let's move on the next topic, the main important topic about the problems the IT industry face today. So who can tell me what they know about the problems the IT industry face today? Anyone has explored that? Anyone? Yeah.
Cybersecurity issues, threats, hacking and all.
Thank you. So yes, those are one of the aspects. But what's going on with the problem what we are facing in the industry? So the problem is increasing the IT delivery gap. Okay. So now going back into the past, how the technology has evolved. Okay. So we will be little nostalgic over here. So you might have seen like earlier we have got that wired phone, landline what we say. Okay. Now we have got mobile phones. We have palm top. We have tabs. We have laptop. The earlier we used to have monitors, the CRT form, the big one, right? Now we have the thin one, and we have laptops now. Earlier having a computer was a big thing, but now a lot of us have that. Okay. Earlier having a mobile phone was a big thing, but now we have touch screen. So that's how IT evolved. That's how technology evolved, and that's very rapid. Okay, there is a rapid growth in IT, and that's where the problem comes. So as the technology evolves, okay, the developer have to work to meet the requirement of the users, the client, right? So when earlier the resources were less, the demands were less, the hardship of that was less. But as the technology are evolving, it's becoming a gap for the developers. So now there are several interface what we can see. We can have a desktop where we can book tickets in Book My Show. We have got mobile phones. Now smartwatch as well. Okay, smart also play a lot of role. So in order to satisfy the user need and to make all this interface use, the developer have to work a lot. Now that's where the problem comes. So in the increasing of IT delivery gap, the conversion of technology happens, rapid growth of digital innovation, set of resource and limited time period. So to learn about new technology or to meet the demand of the user, the developer need to read about it, right? You need to. So if you are giving your exam, now suppose if you are in one semester now, you will be going to other semester. You need to read about that semester, right? You need to update yours, keep on updating. And IT is a platform where you keep on updating yourself every day. Now AI is in boom. I hope you all know about AI, right? Have you tried ChatGPT? Now we have got mobile phones where we have got this AI feature. Recently, Samsung has launched S24 Ultra with a name of AI phone. So think about how the developer is working hard to make that possible for you. It's look very good when we just see, okay, we got this technology, but what's happening behind? Who is doing that? Who is responsible for making it possible for you? In order to match this IT delivery gap, so what would be the solution for that? Either you over outsource, means keep on hiring person who know all sets of resources, but that's not possible. How much you will keep on hiring, right? You can't keep on hiring people every now and then just for some technology, and you need to train them then. Now training is also a big thing. Okay, now it may take some time, some budget. Okay, it's not like in a overnight you can do things. So that's what you also need to understand, like you are in second or third year now. So when you will pass, when you will be in your fourth year, when you will be applying for companies, this all skill set will be very important. So you need to be a step ahead from others. That's what will make you difference. Okay. So we'll talk about it at the last. So as a result, as the expectations are not met, then the growing in IT delivery gap increase, slowing down the business and putting revenue at risk. Budget is a big constraint. Okay, money is a big constraint. Money is involved everywhere. Everyone is doing it for money. So that's a big revenue risk. Now, according to a survey, so only half of the IT delivery experts can fulfill this. Okay, so only half, and even half of them are unable to do that. Now that's again bring a IT gap. That's again bring a pause to the response. Okay, what the user want. The biggest factor responsible for slowing down IT delivery includes a growing misalignment with business team, under resourcing, and time constraint. Okay, so this is a survey which was taken, and what we found is only 50% meet this IT gap and can fulfill on time, and other are still struggling. So that's where MuleSoft come into picture and come for the rescue. Okay, so that will be covered by Acute. Acute, I'm stopping sharing. Give me a second.
Yeah, is my screen visible,
Yeah, we can
Abhishek?
see yours. Yeah. We can see.
Okay, is it visible? I am sharing the PPT.
Yes.
Okay. Okay, thank you, Abhishek, for covering the and what leads the companies to. So, as you have already covered, right, what is
Okay.
the gap? Yeah.
Okay. Maybe you can go on slide mode. Yeah,
Okay.
better.
So, as we
Is
have
it fine
already
for all of
seen,
you? Yeah, carry on, carry on.
hmm, okay. So, as you have already seen, what is the delivery gap, between the demands of the IT and our delivery, right? Since Abhishek, we cannot go and overhire people, right? Whenever we need something deployed in production or to give it to the users. So, what the use case of this? How we can bridge this gap, right? So, the what when we start using MuleSoft, we follow the catalyst approach which MuleSoft provides us. See, the first step is to create reusable asset. So, when I say reusable asset, it means you have to start writing programs into small chunks, which can be reused, and we have to monitor that applications, the small chunks which are being consumed by the developers. So, so when we start the development of any project, right, there are many stakeholders: the project manager, IT team, the developer will code and then deploy it into the production environment. When I say production environment, it means when the direct end user is using that software, whatever you have coded, right? So this monolithic approach before MuleSoft, right? We I say monolithic, it is like everything into one piece of software and deploying it in the production environment which user can use. It is, when you start it, it looks easy and simple, and it is, very in your time. But as soon as we already mentioned, we have now tablets, we have now smartwatches. So whenever the consumption rate, then your piece of software will start behaving abruptly, right? So to overcome this, go into this cycle where we have to start building smart and starts consuming it. So when tablet API or watch want to consume, you can share. Okay, whenever we have to increase the pace of delivery, we have to start from scratch and start building small assets which should be discoverable to every developer. And when a developer want to consume it, he should be a small asset and start reusing. So the main agenda of this to bridge this to create reusable asset and start consuming it, feedback on that, and keep this cycle going on. Instead of building one big chunk of software, we have to build small sets which are reusable across, and then accordingly we have to bridge that gap. Okay, so I'm next slide. So as I said, what about this monolithic architecture before when we soft. So as I said, when we use monolithic architecture, of architecture, in monolithic, what we do, we create one single program. We do a one man job, right? It will have the order status, order history, and it will connect database. So if you use it for the one point to point example, let's say when we are developing a web only, okay, and that web API purpose is to take the data from different target systems like SAP, Salesforce, or Oracle SQL. So from our will call that endpoint which have order status, which will give you order history, and these are all written in one single software, not differentiated it or break it. So this is an example of monolithic architecture. Okay, give you one example if my screen is still visible. So when monolithic, okay, and when I say micro, okay, so I will just give one real time example. In case of monolithic, let's say we have only one service desk, and here multiple people coming and going into queue. Okay, they can have multiple queries, right? They want to see, let's event service takes. Okay, uh, and many people are going to inquire about what is the register, what is the event timing, event setup I'm explaining. Okay, so in case of monolith, we will have only one service desk, one people will sit there, and multiple people from different areas will come into that queue and ask that service desk people what is the event coming up. So you will see it has only one channel of communication between the through this one queue. But when I talk about microservice, we will have, okay, different this will for the registration, this will for timings, this will for the awards, and so different people will come, they will not go into that single. If he has registration, if he has query about awards, he will go to awards. If someone has query about event timings, they will go to event timing. So we have treated the whole application into small chunks. Okay, you see, we have created one micro. This is the second microservice, and this is the third microservice. Okay, and but in monolithic, what was happening? Service desk, okay, which was responsible for querying everything. Okay, so thick and microservice. So as current example which we are seeing on the slides, right? Okay, I will minimize this. Okay, so when we develop a monolithic architecture, we have seen this every operation is performed by one single API only. Okay, the order status, order history, and consuming everything in one go. monolithic architecture, which in future it will give issues when you try to reuse it with the mobile app or your smartwatch app. So it is not scalable, and all the things are tightly. So if even if there is one single point of failure, all your application will fail and you will have downtime for your customers. So to overcome this, so we will see right now we have this web API and introducing mobile API, mobile application to use this app. So you see there are multiple layers of uh, data consumption, and it will lead to chaos when you introduce another watch API. Okay? So the more you consume, the more issue you will get. Okay, so it is very tough to scale. So that's why we are introducing APIs. Okay, so these are all mobile APIs, web APIs, which are following the pattern of monolithic architecture, where everything is written into a single set of software. So when you try to reuse it, you will not be able to reuse everything into one single piece of software. So let's say you have to go to watch API, then there will again a watch API will try to consume again the same thing. He has to write order status, he has to write aggregated customer data in order to consume the data from SAP, Salesforce, or Oracle SQL data. So the more you try to scale, the more problem you will see when you use it. Okay, so that's why we introduce APIs, which using MuleSoft. So I will give you one example where in real world, where you see the example of go to an hotel, and is the you set that is the front end which see the aesthetics of the hotel, where you sit on the table there, right? And then there is the back end, which means the kitchen, where the food is being cooked. Okay, so when you to hotel, don't go to the kitchen and order your call your requirement or your put to the waiter, right? And that waiter goes to the kitchen and it explains the order that this table number requires food. So there is a communication between the you and waiter, and then the waiter goes to the kitchen and delivers your what is expected from you, and then the kitchen prepares the food and then give, and the waiter brings it on your table. So the waiter is API, okay, because you are not directly interacting with the backend here, right? So just imagine and kitchen and ordering, right? There are multiple users or multiple customers in that. So this same thing with the APIs. When we have started using APIs, whatever request we do, we do not go to the backend. We remove the tight coupling. So for example, let's say I am using an site which is built on Angular. I do know Angular, React. All these are different sets of UI technologies, which is built to, which is used to develop the face. We use React, we use CSS, HTML, different kind of UI technology. We have used that UI technologies to build that front end mobile, and then we are connected or SQL database to get the data. A typical example of an web service. Okay, so let me share. Okay, so your client, which can be or your desktop, and this is your backend, which can be, let's say this is SQL. Okay. Right now, what is tight? If you go with tight coupling or monolithic architecture follows tight coupling. Okay. it using okay, and you are connecting with SQL database, and now you have written you are calling this okay Java service you have written, which is consuming this web service, and whatever right you are directly connecting to the response. This is tight coupling. Let's say in future, because technology is over evolving, right? Now in future, if you want to move from Angular, okay, from Angular you use React, okay, or from SQL you want to move to MongoDB, or okay. So since you have developed using coupling without an API, you are directly calling the Java service. So whatever code you have written, you cannot do this change, right? Because you have done, there is no API between, okay. You are directing the Java services to get the data from the from Angular to React or from SQL to Mongo without stopping the application, okay. Since you have not used any API in between, so this is a very tightly coupled system where you cannot move from Angular to React or SQL to Mongo without overhauling your whole system, without deleting it and writing it from scratch, where you have React, use Mongo, okay. So when we go with API architecture, then this is your okay, which is for mobile, and database, okay, which can be Oracle or SQL, whatever it is. So now instead of calling from to Java service and getting the response back, what we will do, we will introduce an API in between, okay. So what we'll do, the client will not directly call this Java service to get data from the database. So client will call this API. API will call this Java, and then this Java web service will give the response to API. API will give the response to client. Okay. So now let's say the same scenario which I was talking, where you have to change the from Angular, we have to change it to React. Okay. So we are not directly interacting with the database. So he can change the technology directly from Angular to React, because the code we have written is very, when we use API, we use a standard software, a standard set of protocol to connect to the database or whatever we are consuming. So when you use API, there is a middleware which here we can use. Right now we are discussing about Mule. So we have other players also, right, in that integration platform. So right now when we deploy the API in between, so whatever change of scope is happening, it will not active, there is no direct tight coupling between the front end and the back end. So when you call, let's say we are calling the do get method to get the data, okay. So we are calling the do get method of the API here, and then API is calling the do get method of the database, okay. So when we change here, let's say from Angular React, so we still will call the do get method of the API, and then it will call the do get method of the database. So there is no direct integration between this do get method and this. So when you use API, you have the flexibility to change the front end or the back end, and your API will work as a middle, and it will since we are using API, this is A, this is B, and this is C. Communication between A and B will be broken, and it will be replaced. The communication between B and C will be still intact. Okay. So there is no, you don't have to run scratch. Okay. You have to only write A and the B communication when you try to switch. When you try to switch between Oracle and SQL, so you only change the B and the C part, right? You don't have to change the A and the B part. So this way, when you use API, you have the flexibility to upgrade your technology. Okay, and this way you will have less time to market, which is our main goal. Okay, whenever we think about perspective, when customer is paying you money to develop something, the the expectation is less time to get and less complexity when you deliver the code. Okay, so when you remember the other example where the client was directly interacting with the web service, and that was connecting with end. So the method you have written, a to b point to point communication, which is the monolithic way. And when you use the API, you don't go to point, create small chunks of the APIs, okay, which will be consumed by this, and then this will call this. So you are adding a lot of differentiation between the client, the customer, or the client and the server, so that in future if you want to scale up, or you want to have one more API, let's say this is your web app, you have the mobile app also, or you have the watch app also. Okay, so this same watch can consume the same API, and the same API can call the backend. So using APIs, so since we are moving detail what is API and all, you can uh, understand the use of API is to connect to systems. And here the two systems we can mention as source and target, where the source is in different region and target is in different region. So we have to use an API to communicate between the source and the target. Okay, I will move to this. Okay, and let's move ahead. So I hope you understand the importance of API in. And so since we are specifically talking about MuleSoft, so API can be developed using other technologies also, right? Delbumi, which Abhishek mentioned, Delbumi is there, Tipco is there, and even you can write, these APIs in Java and Spring framework also. But why we are focusing on MuleSoft, as we have already mentioned, it is a low code, no code platform, right? Where you don't have to write the repetitive work, the donkey work you don't have to do. So when we will show you how an API looks like when you start developing it using MuleSoft, because it's a drag and drop platform. And as Abhishek mentioned, this data weave to transform the request response. Rest everything is drag and drop. Drop one thing from the palette which is available in MuleSoft. It will write the code in the backend. Okay, we will see all those. So the importance of API and why it is needed when you develop something, that I was trying to explain. Okay, any question on this, how
Yeah, Akib,
huh?
just hold on. Okay, can you go back 2 3 slides to the monolithical approach? Let's
Hmm.
make it very clear, like how good they understood. Uh, to the other slide, uh, down to this. Yeah. Okay. So, Akib talk about monolithical APIs, microservices, API. So, who can make me understand what they got about monolithical APIs and APIs? Let me ask someone else. What's your name? Okay, you can go. Thank you, Raj. Then monolithic. Thank you, Rishabh. Okay, so when we talk about monolithical, okay, Akib, one slide back, please. Yeah. So when we talk about monolithical, so Akib has used the word tightly coupled. Okay, that's a IT jargon we can say. So when we say about tightly coupled, think it in this way, like where things are dependent. Now one layer is dependent on another layer. Now you can use this. You can say this as a layer, okay, where one is your orders, one is your order history, and then aggregating the systems. So down what you see over here, these are the AND systems like SAP, Salesforce, or any other server. Okay. So when we talk about monolithical, so they are tightly coupled in a way. So if we want to create an application for web services, so what the developer do, like they will create it for that particular use case only. Okay, where it will work for web services, where all the layers or all the systems are connected tightly, dependent to each other. Okay, and if anything break, the whole system will be down. Okay. Now, if someone want to create the same response, but for a mobile app. So what they need to do is they need to repeat this task again. Okay, they cannot reuse it. They need to repeat it. So that's why we need to report. As an innovator, as a developer, we don't go with repeating tasks. Okay, we go with reusability. So now you will see. So this and this both are same, calling to the both system, the same system, but we are creating a dependency over here. So that's what monolithical, dependent. Okay, if one breaks, all of this will break. Okay, so that's what MuleSoft come into picture to remove that dependency. Okay, so now I think you can explain about monolithic. Okay, so Akib told about APIs. So when we do integrations, we spoke about integrations, right? We are doing integrations. So we create APIs in Mules. Mostly we create RESTful APIs. REST APIs like your HTTP, HTTPS, POST, PUT. You might heard of it. GET. So those are APIs, application programming interface, which help us to connect the systems to do the request and response the thing to get it to the user. Okay, that's where API come into picture. So back to back. Okay, yeah, you can carry on about introduction, introducing yourself.
Yeah. Okay, so we have seen, the example of an API, right? The very generic example that we use every day to give in a layman terms, right? When we go to a hotel, that example I gave you, the waiter is an API, which is a middleman between you and the kitchen, right? Whatever order you are placing, whatever input you are giving to that waiter is taking to the kitchen, and taking the response back from the kitchen and giving it to you. That is the whole job of an API. Okay, to take the request and give it to the back, and same thing, right? So for example, if you go to a different hotel or a different place, the waiter is same, right? The API is same, only the front end, which we where the place you are sitting, the aesthetics are changed, and the kitchen is changed to something different, right? Example that I gave you for of switching from Angular to React, or switching from SQL to Oracle. Okay, but the API which you are used to call, you will call the same API, the waiter, and the waiter will give you the order. So for you there is no change, but the back end and the front ends are changing forward, moving whatever the technological advances are coming. Okay, so moving to the next, why we need APIs, we all know. So let's see some examples that why we have APIs in the first place, right? As I also, the API are part of subset of the web service. When we call what is web service, then we can see, right? Web service allows you to uh, establish the connection between two source and targets, right? Source can be written in Java or .NET, whatever it is, right? The target understands only, let's say, .NET. The source is written in Java. Then how these both system will interact, right? Because both are built on different technologies. So when the picture of web services comes, so web services are the parent of APIs, I will say. Okay, you can understand this. The web services comes into picture. So let me share my screen. Okay, okay. So let's say this is one system, and this is one system. Okay, this is written in .NET. This is written in Java. Okay, now this is system A and this is system B. So if we want to establish the connection between A and B, so we cannot, right? Because it understands .NET, it understands Java. So to establish the connection between A and B, to let the communication happen, let the data exchange happen between A and B, what we have to do, we have to develop a web service. We have to develop an web service. What web service? It will, standardize the communication. Okay, to communicate between A and B, the communication should happen over XML or JSON. Okay, so there should be an independent request and the response structure. Okay, so to communicate between A and B, we have to go via web service. Okay, web service can be achieved using SOAP. Okay, right now, and SOAP is a different architecture mechanism. We will not go into this, otherwise session will go long. So web service is the parent which can be leveraged using SOAP and REST, and under REST we start developing APIs which are REST APIs. When we talk about Mule, okay, SOAP also have APIs which are SOAP APIs. Okay, but when we talk about MuleSoft, so MuleSoft focuses on the REST APIs. So we can consume the SOAP APIs also from our REST APIs. So that is all. But the main agenda which we are trying to explain, where APIs come into picture, right? When we communicate between two systems which are uh, to each other and built on different technologies, right? Then if they have to communicate, they have to use web service, which will standardize the communication, the request and the response. Okay, either in XML, JSON, or whatever the agreed way of communication is. And then web service can be implemented using SOAP or REST. And then when we use SOAP, we build SOAP APIs. REST, we use REST APIs. We will, you can go ahead and check what are the difference between SOAP and REST. Both are targeted for different use cases. Okay, so this is the use of APIs in between, right? APIs allows you exchange data between two systems. Okay, and web services are the ways. Okay, web service is the parent of the API. Okay, so there are different jargons you will keep listening: web services, SOAP APIs, REST APIs. So you can just, in a layman term, web service is a standardized protocol to communicate with B, and to implement web service we have to go via SOAP or REST, and SOAP has its SOAP API, REST has its REST API. Okay, both SOAP and REST are used in different use cases, and when we talk about MuleSoft, we are talking about REST APIs. Okay, any questions on APIs?
Any question, guys? If not, then I will ask. Okay, Akim, carry on.
Hmm. Okay, so let me move back. Okay, so we have seen APIs are the building blocks, and they serve digital glue. Glue means they connect to systems and allows the exchange of data. And APIs are the web service, right? They are the subsets of the web services. Okay. So now we will go back to the example again of the monolithic approach which we were seeing, and we will see how when we go through MuleSoft APIs, how we can resolve the problem using the Mule API-led connectivity approach. When I say API-led connectivity, it means we are making APIs into small chunks and making them connected. Name defines the same thing, right? API-led connectivity, which means when you are connecting between the source and the target system, we are using a layer of APIs in between, so that the main purpose is to make APIs reusable. Okay, and the importance of reusable, right? It comes into picture that it will fasten your development, right? Because time and money is the two essential things when you work for a client or any customer across whatever is technology, whatever wherever. It is not about technology. Wherever you are working in any of the field, time and money are the two constraint, right? When someone is giving you money to get a work done, the two thing will be less money, less time. What is the basic requirement of every customer across the world? Okay, so that's why we have to introduce reusability. So when you break your APIs into or segregate the APIs by its functionality or the use of that, and you create small APIs. So in future, let's say currently we have differentiated into three layers. Okay, experience APIs, process APIs. And earlier what we were doing, one API was used to connect with the database, same API was used to modify the data of the database, and same API was to give it to the or the front end. Okay, when I say front end, it means your client, the browser, the Google Chrome or whatever browser you're using. That browser is calling that API to get the data, right? So earlier, what was happening? Everything was through one single API. Okay. Now what we have done, we have defined different layers based on what that layer is doing. Okay. So let me again go to this. Okay, I will. Okay. So this is earlier opening. This is our client. Okay, and this was our one API which was doing order status. Okay, and history, whatever it is, all those operation into one, and it was connecting to the backend. Okay, this is our backend. So when we try to introduce mobile API, then since we have written only one API specific to the web app, so again we have copy paste the whole code for the mobile API, right? And write it again for based on the mobile use cases, and again connecting to the same applications, right? Same database again. Okay. So this was the monolithic approach. Now what we are doing, we are differentiating the APIs based on their functionality. For example, we have created system APIs. Okay. What is the role of system APIs? One small API which will connect to the database. Okay. This is our API. Okay, and this will connect to the let's say SAP database. And we have written one API which will connect to the Salesforce, let's say Salesforce database. Okay, so this is we have written two APIs for connecting to the systems, the target system. Okay, this is our target system. So now, and we have written one API, or let's say order status API. What it will do, it will call this SAP API, and do some modification. Let's say first name and last name. First name and last name is coming from the SAP database, and in order API, what we are doing, we are doing first name plus last name into one name column. So this kind of modification which we do, right? Because in the database, the names are separated into two columns, first name and last name. But in order API, what we are doing, we are combining first name and last into one name column so that UI can consume. Okay, and then we have this experience API where we are giving the data right now to the web application. Okay, your laptop. So here we have written one API for web application, one for your laptop. Let's say this is your laptop API, and this laptop API is consuming this order API. Okay, so this laptop API now is getting the name object. Okay, which has first name and last. Okay, so this way, Now see, you say, okay, this we are increasing complexity, we are creating too many APIs, but all these APIs are reusable. Okay, so let's say in future when we have mobile API, let's say we have mobile, so we have to create only one mobile API, and that mobile API will reuse this order API, and this order API is already calling the SAP. We don't have to write order API for mobile and then order API for SAP, right? If you, in the same old case which we saw, we have to write everything, copy paste, do the repetitive work of the same thing, and this will lead to more time in developing one single mobile API. But when we are using this API layered architecture, okay, we have to create only one mobile which will call this order API, and then order API is already calling SAP API to reuse it. Now let's say we have this watch API. Okay, now watch API needs data from Salesforce. Okay, so watch API, we will create one watch API here in the experience layer. Okay, and this watch API, okay, and we will create one API for the Salesforce order API. Okay, one more API will, it will call this Salesforce system. So if you see, the system is now very clear, very architectured. Okay, there is no cross communication, and the scale you see is very high. A new system is introduced. Okay, whether it was first, it was your browser, web application, your laptop or mobile or your watch, or let's say some new customer or new interface want to consume, so they don't have to write this backend systems again and again. Okay, because these are a small set of APIs which are already being consumed by order API, so you can reuse these APIs. So when you reuse the API, the repetitive work is not there, and when there is no repetitive work, you are able to discover these APIs in the exchange. And when I say exchange, right, so all these APIs which we are developing, we will have one marketplace like Google Play Store, or in Android we have Apple Store. So all these APIs will be available in that exchange is a marketplace. Okay, so whenever a new API comes, it will go to exchange and search, is there any API which connect with SAP, or is there any API which connects, which does this modification of first name and last name, and fetch the data from SAP. So yes, you will find that API and you can directly reuse that API. So by this, we have removed the tight coupling. You see here we have this tight coupling. One API was responsible for doing all these things, so you use it in mobile interface or watch interface, right? You have to again the whole code and then do some modification in the code. And when you have these kind of approach, if anything fails, right, let's say, or this thing is failing, but since you have written everything into one single block, this whole block will fail. Okay, now if something is failing into Salesforce, your SAP API is still active. Okay, if something fails in SAP, your SQL API is still active. So your end-to-end failure will be minimized. Okay, only one small chunk will fail, so that will not uh, mismanage the whole architecture of your application. So that's why we move into this API led connectivity. Okay, if I go to next example, you will see when we introduced mobile APIs on this app, so you will see everything is still reusable. Whatever is order status is there, it is able to consume that. Same web app is also consuming the same order status API. So if we are not using API led connectivity, I've seen in earlier examples, right, how crisscross happens, right? If you same thing you have to write again and again, and do the same repetitive task. So that's why when we go Mule, we have this a connectivity approach where we segregate the APIs based on their functions, and whatever the modifications we are doing, and what is the endpoint which the API is using. We are giving you the typical example of mobile and web, but when we go into the actual real world of projects, you will see multiple end users. Okay, when I say end users, for example, in our project we have SAP, we have MongoDB, we have other Salesforce, Oracle. All these are our target system, and the end users are different client, because we work for an insurance project which has multiple source and target system. So we have developed APIs in that same API connectivity. So in future, if any other agent is coming, then we don't have to expose the all the other things. For example, I will give you one real world example. Google Maps, right? Google Maps, if you see, Ola is also using Google Maps, okay, in their app. Uber is also using the same Google app. And if you see Zomato or Swiggy, right, everyone has this Google Map in their app. So GI has exposed its endpoint as APIs to them. Okay, so don't have to write everything new for any of the end users. So Google API is your target system, and Swiggy or Ola, Uber, whatever is this, right? They are your source which are trying to consume the Google Map API. So if Google Map API is started delivering, point to point. Let's say if Uber comes to Google API and say, I want to consume you, and Google has written only one simple endpoint for Uber. Okay. So, and in future, let's say Ola is coming or Zomato is coming, so they have to deliver point to point again. So it will be hectic work for Google, right? So they have exposed APIs which Google also can consume, which Uber also can consume, which Zomato also can consume. Okay, so that's why they have used this API-led connectivity approach to remove the bottleneck of if anything new comes up, they don't have to write everything from scratch. Okay, they will just write one single experience API, and everything will be reused in the flow. Okay, any question on this API-led connectivity, why it is needed, and how it is solving problems for us?
Okay. Any question on this? Yeah. Your own API, right? So there are tools to do that. Okay, we'll discuss about it. Okay, how you create APIs, where you can create APIs. Any question on API-led connectivity? Okay, will do. Any other question? Have you understand about API-led connectivity? So see, please feel free to ask question. Okay, no one is judging you. We are here to make you learn about things, because or maybe today you won't realize it, but very soon you will. Okay. So what we do in API-led connectivity is, so we have seen there is a monolithical approach where we tightly couple the layers. Okay. But in API-led connectivity, we have divided it. So this is known as loosely coupled. Okay. So what we do is we have three different layers: experience, process, and system. So your system API talks with your end system. Okay. Maybe Salesforce, SAP, USP, any other server. Okay. So we can say it's replicate the system. Okay. Then we got the process API where we do the orchestration, we can say. Okay. We create the business logic, the transformation, what we need to do, how your user want to get the information, that all we do in the process API. And then coming to experience API. So experience API is something which through which the user will send the request. That will be something exposed to the user. So like in this case, you can see there is a mobile app and there is a web app which is connected to experience API. That means that is something will be exposed to your user, where the user will send the request. The URL, if you know about URL, okay. The URL of the experience API will be shared to the user, which will be connected to their system, whatever it is. And from that, we will get the request. And again, from that only, we will send the request. We'll not expose the process and system there. These are hidden from the user. They don't have any information of it. Okay. So in API-led connectivity, what we do is the systems are same. Okay, the system layer systems are same. It is getting reused. So that's what MuleSoft bring the concept of reusability. So the process API over here, if you'll see, the SAP and Salesforce is getting utilized by customer process API. Okay. So one more benefit of this is if one system is going down, it is not going to break the entire system. Only that particular part will be down, but other will be working. Even though in this you can see you have to create two different experience API for mobile and web, okay, which are almost consuming the same process API. So again, a reusability. Okay, so that's where the API-led connectivity come into picture. Yeah, Cube, you can talk about the next.
Yeah. Okay.
1 minute, 1 minute. There is a question.
The question that web service will be using HTTP, but the APIs are using HTTP and HTTP is a tool while web services will be a whole application provided by the user.
That's a good question. So when we expose thing outside the world, so there are two things. One is HTTP, one is HTTPS. When we say HTTPS, that is secured. So security is very much important, right? So we got this two aspect of creating APIs. Maybe if you want to create internal APIs, you don't want to have some uh, security layer over there. But when we do it for experience, we want like where you use your one-way, two-way SSL. There is a concept of that. Okay. So you don't want to keep it open. You want the message to be encrypted. Okay. That's where the logic of HTTPS and HTTP come. Got it? So mostly all the experience API, which is exposed to the world, which is exposed to the user, need to be secured. There are several security aspects which are used over there, and we can say yeah, it is HTTPS. Okay. Maybe Acube, you want to
Mhm.
add some?
Yeah, I got the question right. At which layer we want to secure the applications, right? So
Yeah,
the main.
the question is why we have two things like the HTTP and HTTPS. What's the
Okay.
significance of that?
Okay, okay. See, the explanation that you gave, right? HTTPS means HTTP over secured layer. Okay, and there are different aspect to security also. When we say HTTP, that is simple protocol without any security over it. And when we use HTTPS, we have to either go with one-way secured socket layer application or two-way secured socket application, where there is exchange of certifications first, and if the certifications are whatever the server and the client are exchanging in between, if the certificates are trustable, only the communication will start and the handshake will happen between the client and the service. Okay, so we use HTTPS, then we have to introduce the certificates which the client and the server share. Then only the communication will take place.
Okay, okay. We have one more question from Ayush. Yeah.
Mhm.
I want to ask, as just you explained that if some part goes down in the layered approach, then the whole system or the whole service will not go down. But what if some part of the system, sorry, service, the last layer of the exchange layered approach goes down, the system layer, then the whole API will go down, I think.
You're talking about the system layer. See, again, like the system layer is replicating main system. Right? So if Salesforce is down, suppose, then when we are building whatever is consumed by Salesforce, for that it will not work at that particular time. Okay, there would be some downtime, but other it will not affect other like it will not affect SAP or your other services which are over there. Okay, got your point? Yeah, Cube.
Yeah, yeah, the question is very simple, right? When the system goes down, because that's why we have segregated into small. If let's say Salesforce goes down for that some period of time, then we have those error handling techniques applied, right? So we will try to for example, we have different routing techniques in MuleSoft. Okay, let's say we are trying to consume one instance of Salesforce that is down, then we have those edges also implemented. If one of the route is consuming Salesforce, we will try to consume different route of sales. So that all we can manage based on what customer needs. But the question is very valid. If one system goes down, so it will not affect the SAPs or the SQL systems, right? So those will work, and for Salesforce we will have a downtime and the error will be
It
displayed
will not
to
affect
the
the other process.
correct. But all those can be handled. If customer says no, if it goes down, then you have to hit this different instance of Salesforce, which is called disaster recovery. We have multiple, when we dig deeper, we have different approaches to handle all these failure scenarios also. Okay, the other approach is to, let's say when we are getting some data from Salesforce and trying to put that data into UI, so we can introduce, some intermittent storage of that data. Let's say we can some temporary storage of that data into our MuleSoft. So whenever it goes down, also we can fetch that data. That we can also use caching scopes. All those different techniques based on what customer needs to resolve that failure scenario. But yes, if the failure happens, there will be downtime.
Okay, you can go on the next
Any
slide.
more question?
Any
Yeah.
more question? No, no. Yakub.
Okay. So this was, this elite connectivity which we discussed. So we have three different layers. Layer which unlock the data which Abhishek mentioned, which replicates the data from the backend. Because see, the backend is the most sensitive part of any organization. Let's say you are building an application to get the data of. Let's say we are building an application for an hospital. Okay, where we can search the patient name or whatever data we are building. So that data of the patient, because data is money in the current scenario, right? Whatever data is stored anywhere is that the real value lies with that data. So we have to segregate the data layer. It is very obvious, we have to segregate the data layer, and then we can add multiple, which the earlier question was, right? HTTP or HTTPS. So we can have process API to system API. We can have the HTTPS communication, so that no one else is trying to manipulate the data or get the illegal way of attaining that data. The experience API can be HTTP, right? Everyone can access the experience API, which is just calling the order API. But if we have not segregated the system APIs, we will are not in that way to implement different rules and sets based on the sensitivity data. Okay, let's say Salesforce requires multiple security when we interact. So when we have built small Salesforce API, then we can implement all those security mechanism on Salesforce API. Okay, let's say that SQL is containing only first name, last name, and normal address of the customer, and that Salesforce is containing your payment related or anything. So if you have divided your APIs into small system APIs, then you will be able to implement different rules for different kind of APIs. That is one again added benefit when you use this API-led connectivity. So your system APIs will be more secured. You can apply multiple level of security, multiple policies on the system APIs. So similarly, process APIs, where we see when we get the data from the database, it is in raw format, right? We have multiple columns, we have multiple tables to deal with. So in process APIs, what we do the transformation of those data, cleaning of those data. For example, the mobile apps required only 5 fields, and the experience API requires 10 fields. So on in process API, we will map only those 5 fields from the database and those 10 fields from the database. We will not expose any unnecessary data to the environment. So we in the process APIs, we reuse the assets as we have already seen, and we compose the information, which means we transform the information which we are getting from the system APIs. And then in experience API, it is for consuming those APIs, whether it is your tablet API, mobile API, laptop API, or your watch API. Okay, anything, any questions? We have already discussed this.
Yeah, we have one question. The data format, right? So when we talk about REST API or RESTful API, so the format can be it supports a lot of different formats like JSON, XML. Okay, there are multi parts. You can upload a file as well. So these all are the schemes or the format what an API can use over here for RESTful. When we come to SOAP, so there are two aspects, SOAP and REST. So when we talk about SOAP, that is only XML understandable, and when we talk about REST, it's irrespective of the language. I hope that answer. Yeah. Okay. Any more question? Yeah. Okay. We have one more.
You mentioned REST API and SOAP API. So REST stands for representation of state component. So what does SOAP stand for?
What is SOAP stand for? Maybe Aki, we can give the full form. Can't hear you.
Hello.
Yeah.
Yeah, SOAP stand for Simple Object Access Protocol. As we have seen, I have already explained, right? To implement the web service, right, we have to use two different architectures, which is simple SOAP API, Simple Object Access Protocol, and then we have REST, okay, which is architectural, RESTful, stateless architecture. So, based on these two different ways of implementing web services, so every when we use SOAP, it has its own features, security mechanisms, and it only works with XML. It was, prior to development of this REST. So still people use REST in older architectures, but whatever new systems we are building, everyone is using this REST APIs. So SOAP is an standard, which is, as the name suggests, Simple Object Access Protocol. It is a protocol which is used to communicate between two APIs to end systems which are unknown to each other. As the example I gave, one is written in Java and one is written in .NET. So when we use SOAP, then this Java system has to communicate its request into XML, and then the .NET system has to respond in XML, so that the information exchange happen over XML things. Okay. So when we use SOAP, we have to go via XML kind of request response structure.
Yeah. And adding to that point, so SOAP is a protocol, whereas REST is a transporter. So protocol SOAP, if we consider in that way, SOAP is considered to be more secure as compared to REST. Okay,
Correct.
and we have different connectors in MuleSoft to carry that out. SOAP uses WSDL, whereas REST mostly uses RAML. Okay, and that's a designing pattern where it's a blueprint we can say, which tell you about your API protocols over there. Okay, yeah, okay.
Okay, my I think I have covered my part, Abhishek.
Yeah, sure. I will take it over now. Then.
Hmm.
Stop sharing. I'll share. Okay. So when we talk about web services, API-led connectivity, integration, so it come with a application network. Okay, it works. The application network come into picture. Okay, all this creates an application network. So what it is? Application network is a way to connect application data device through APIs that expose some or all of their assets and data on the network. It represents a cultural shift. So what that means is we talk about the old monolithical approach or maybe the tightly coupled thing. Okay, so it create a shift from the old to a new approach. Okay, to a new IT operational approach, which help to get it going, make it loosely coupled. and help the user to achieve what they want. Okay, so it emphasizes not how many assets are present on the application network, but rather how many consumers are getting value from it. So it's not about just creating APIs. Okay, it's not about just building the APIs, but is it actually solving the problem of your users or not? The difficulties, the IT problems, what we have, is it actually solving that or not? And is recomposable, so it can bend but not break. Okay, you can bend it the way you want, but it will not break. Okay, that's what the application network come into picture. Now, API development lifecycle. So we have got three different approach. We have got concentric circles over here. So the inner layer, the first one is the design, then develop, and then deploy. Okay, it follows a life cycle. It follows a structure. Now think about like this: if you are constructing a house, okay, so what do? You just start getting the raw materials and build the house. No, you first create a raw material, right? Sorry, blueprint, like how your house should be. There should be an architecture for that. There should be a designing for that. Even though if you are creating assignments or projects, what details you want to have to the requirements, like what the topic is, how much time we are going to get. Okay, what all things you will require. Then you create a structure. Okay, points or sub points, like how you are going to do that. So similarly, when we create APIs, we work on the life cycle. So design first approach, constant feedback, self-service and discoverable, iterative, reusable, and consumption. So what this means is, so in for RESTful APIs, we create RAML. So what RAML is? RAML is a blueprint which will give you a knowledge like what endpoints you are using, what methods you are using, how your API will be looking like. Okay, you can mock the services, you can uh, test it over there. So when you design, you simulate that, and then you send it for a feedback. Okay, to validate like what you have created is what required by the client. Is it matching the requirement or not? Okay, so once we design it, the design is final, then we build the APIs and test it. So testing is very important. Okay, before releasing it or deploying it, the testing is very important to let know what are the different bugs or what can break the APIs. The testing, like if you're creating any software or any ID, so you test it on different devices. Like for desktop, you are creating applications. For mobile phone, for your smartwatch, so you will test on different devices to see the interface is coming right or not. There should not be any bug over there, or there should not be something breaking. Okay. So after building, you do the testing, and then comes the deployment phase. Okay. So there are several way of deploying the application. I hope you might have heard about cloud, right? There is a on-prem. Okay. There is RTF. So there are different approach of deploying your application. Okay. So here also there are different approach, and that will be very deep. So I'm just not going into a deep dive for that, but approach of doing that, cloud, on-prem, RTF. So different models are there. Okay, so uh, that's where the API development life cycle helps. And then from the catalyst approach, so this is something which MuleSoft has introduced. So what is the main aim of any client or any services? What's the main aim? Now suppose if you are doing a business, what's your main aim apart from that? So the main aim of any business is customer satisfaction first. If your customer is not satisfied, you can't make money, right? So how you will make the customer satisfied? How you will make the customer success? So that's where this catalyst approach come into picture. So it's a framework and methodology which tells you about the three different pillars, okay, of making a customer success. The first one is business outcome, the second is technology delivery, and the third one is organization enablement. So business outcome, what it is? So it's talk about clear outcome and KPIs, okay, key performance indicator. So when you create any applications or when you start any business, what you need to keep into mind, you need to clear it, clear about the requirements, what your user want, what will the budget, what is the timeline, like by when we need to deliver it, what all functionality we need to do, right? So all this requirement need to be there, then only you can build something. You can't just keep building something of your own, and if it doesn't meet the demand of your client, it's of no use, right? So that's where the first pillar, the business outcome, comes into picture. Then comes the technology delivery. So as someone asked, like how we can create our own APIs, right? So there are different tools, okay, for integrating, for creating the integration, for creating the APIs. Like for MuleSoft, we use Anypoint Platform, Anypoint Studio, okay. So we need to be very careful, like what tools we are using or what tools we will be requiring in order to create these applications, okay. So that is important to know our tools on what we are playing and what we are using to create the application. Then come the organization enablement. So we have a C4E, Center for Excellence, okay, Center for Enablement, sorry. So your C4E team is someone responsible for taking care of your assets, like what assets you want. There are some standards, okay, best practices which we need to uh, carry on, or we need to follow when we're creating the APIs. So there are different checkpoints, okay, which are mentioned. So C4E team help us with that. Then internal support and training. So although you have created an API, so there should be someone to maintain that. A maintenance is required. It's not like you have just created. Even though if you create your house, you need to have maintenance, right? You need to see if there is no leakage, something is breaking out. So the same way, when we deliver it to client, we need to have an internal support to take care of that APIs and reach out to the developer if something fails. Okay. Then comes the training. So we need training to know about the API. We can train our client about the API we have created to give them a knowledge like what we are doing over here. Okay. So we have a catalog which talk about that, and you can get it online. Okay, you can get it in Salesforce as well. So any question till now up to this? No question? Are you still with me? Okay. So now we talk about so many things. Yeah, some of them are little high level because maybe you haven't reached out to that point where you can understand it. Okay, but this is something which will be very useful in coming times. So, in order to learn about this technologies, mainly for about MuleSoft, how you can do that? So the first thing we have is a Salesforce Trailhead account. So Salesforce provides this ability for individual to learn about it, and there uh, we have a learning platform from Salesforce, which is Trailhead, which can be useful to learn about Salesforce and MuleSoft. Okay, just you need to create an account. Okay, and you can learn on different aspects of this. So if I show you, so this is how a Trailhead looks like. Trailhead.salesforce.com. Learning, you can see there are different trails. Okay, then trail mix modules. So these are all for learning. Okay. There are different modules which you can use. Okay, this is about like learning about your profile, learning about Salesforce. Okay. You can go on trail mix here also. You can get different learning options where you can learn and this technology. The other come for MuleSoft. Again, similarly, we have a MuleSoft platform, but soon this all will be integrated to Trailhead as MuleSoft is a part of Salesforce now. So here also we have a learning path. We have different courses over here. Okay. So you can go with the self-paced one wherever it is written self-paced. So you can know about what is Anypoint platform. Okay, the fundamental of Anypoint platform development, like where it will show you like how to use the platform, how to use the studios, how to create your own APIs. Okay, and this is something how the platform looks like. Okay, we have different options over here. I will log in and show you. Apart from that, we have got Studio. this is a tool where you create your APIs. Okay. So now, very recently, MuleSoft has also introduced, like Salesforce have also introduced a Anypoint code builder for developing your APIs. Okay, that is something a recent one and a future. So this is how the interface looks for like. Okay, so all this is available online. Okay, you can get an idea of it, and then uh, we are just at the end of our session. So we have a LinkedIn page for our MuleSoft community where you can add. Either you can scan the QR or you can go to this link. You can follow it. So whatever recent things we have or whatever updates we have from MuleSoft, what events are happening, you can get everything over from this link. Okay, so now let's come to the summary part, what we have discussed so far. So we spoke about the API basics, the API-led connectivity, the Catalyst book, the IT delivery gap, life cycle, about the learning path, how, what are the tools to create the APIs. Okay, that's what we have understood so far. So now, if we have any question,